Now we've had a look at a few G codes and we've got a basic understanding of how some of these things work. The best way to really get a grasp of how this works is to write a full program. So we're going to do that with a rather simple part. This has just got a few straight line moves and a few radiuses and very simple measurements, but it'll give us an idea of how these G codes and M codes work within a program. Now G codes can be a little bit complicated in the fact that each machine prefers its own way of writing the code. But things like general G codes and M codes don't change, it's just the style of the layout that may change slightly between machines. Now all machines have their own particular style of G code that they like. So what I've done with this lesson is I've checked out the way Mac free system likes to read programs, and I've copied that general style within my program. Should be able to read by any Mac free controller. A good way of getting to know the style your machine likes is by outputting a file in Fusion 360 using the post processor, and then it prints out the program that the machine likes to read. Like for example, the safety line would be set up the same, and certain M codes and G codes that like to be active at the beginning of the program will be there. So you can get a general idea of how your machine likes the program to be written by outputted files from Fusion. But saying that, it's best not to get too bogged down with this concept. So I tend to teach generic G codes quite often, so you can put it into any project or any machine and it gives you an idea of how it works. But just be aware that each machine likes it written in a certain way. Okay, so our part on the bottom left hand corner, we see the datum. This is where I've set the 0 position on this particular part. So x0, y0 will be on this datum, and z0 will be the top surface of the component. Now I'd like to keep z0 on the top of the component. That way, if we see any negative numbers in z, we know it's cutting and it's inside the material. So at a quick glance at the program, we can tell whether the cutter is removing material or it's above the job in a safe place. So let's have a look at the first line of every program. Now the first thing the machine sees is the program number. Now this is in brackets, which means the machine doesn't actually read this. Things enclosed in brackets are operator's notes. It's not read by the machine. The machine knows which program this is by the file name that we call it. So I've called this program 2001, and at the end of this line we have a semicolon. This means end of block. This tells the machine this line is at its end. So after every line of G code we add an end of block code or a semicolon. Moving on to the next line, we have another operator's note. Everything is in brackets on this line, so it's not machine readable. This is purely for us, so the operator knows what's going on. So the information we're telling ourselves on this line is that T3 is the number of the tool we are using, D is the diameter, and then a description of the tool. And we end with end of block to tell the machine this is the end of the line. So the first thing we tell the machine is G90. This means that we're using the absolute position system. So all dimensions come from our datum position. No matter where the cutter is or where we're going to tell it to go to, all dimensions run from our datum. So x0, y0 on the bottom left hand corner is our datum. So all the dimensions run from this. The other option here is G91, which is incremental, which would run from the last known position of the cutter. So if we were moving the cutter 10 millimeters to the left, we would say x minus 10 rather than give that dimension from the datum position. So we're going to work an absolute measuring system. Both are used quite often in programs, but I believe most CAD/CAM programs output as absolute coordinates. Now this line of code is our safety line that I spoke about in a different lesson. For a more in-depth look over how this initial safety line works in a CNC machine setup, check out that lesson. So our next command is G94. This tells the machine that we are working in feet per minute. This is how we control the machine cutting tool when we are actually removing material. So when we issue a feed rate, this is how it reads that feed rate. Okay, so in other words, this is telling the machine when the cutter moves from A to B to do it at so many millimeters per minute. Or if we're in imperial, it would be so many inches per minute. The next G code here is G91.1. Now this tells the machine how to work out where the center points are of the radius. Are they in absolute or are they in incremental positioning? Well, the standard way for radiuses seems to be incremental. Both absolute and incremental are often used, but I see incremental a lot more than absolute. So this tells us that when we define the center point of a radius, we define it from the measurement of the last known cutter position and not the datum position. So if we're at the start of a radius and the center of the radius is 10 millimeters to the right of the cutter, we would give it a value of I10. I, J and K are used to define the center points of radiuses, and they mean the same as X, Y and Z. So I is X, J is Y and K is Z. We'll talk more about that later in this lesson. So here we have G40. Now this G code cancels any active cutter compensation. So when we program, normally we program to the center line of the cutter and tell the machine the diameter of the cutter so it knows how much to offset it by. That way we can program to the actual dimensions of the part and we don't have to allow for the radius of the cutter. Well, G40 just cancels any radiuses that the machine may have in its memory of the cutter. So G40 means cancel cutter compensation. Now this safety line is normally the most complex part of the program to initially understand when you're new to G-code programming. But it's okay, you can always copy and paste this line until you understand fully what each G-code means. Next up we have G49. Now G49 is tool length compensation cancel. It cancels any offsets in the tool length. Now tool length offsets are very important because it tells the machine how long the tool is and where the exact tip of the tool lies in the 3D environment. But this line just cancels any offsets that may be active, so we can start afresh. G17 is our working plane. Now G17 means the XY plane, in other words the flat plane of the machine table. So Z is always up and down, and X and Y just tells the machine that we're cutting along this plane. So when we're using I, J and K values to define the center points of a radius, this lets the machine know which plane we are referring to on them. With CNC routers, we always work in G17, so this is always the same. Now depending you prefer working in metric or imperial, this G code tells the machine which one we are using. G21 is the metric system and G20 would be the imperial system. So it reads any dimensions using whatever system we defined here. Now I tend to work in both imperial and metric, but in this case, on this program, we're going to work in metric to keep the numbers more readable and more simple as we're going through the program. So I've decided to write this program in metric, so I'm using G21. Now with the machine set up, we can start writing our program to make this shape. So first I'm adding an operator's note to describe this operation. So I'm just going to call this profile. Sometimes we can add tooling information here, but where we're only using one tool, that information was added at the beginning of the program. So this operator's note just tells the operator which block of program we are about to write or run. Our first M code that we're coming across in this program is M05. This just tells the machine to stop the spindle. There's a very good chance the spindle is already stopped at this point, but if it is running, it will stop it now so it's safe before we start running the rest of the program. Now all M codes and G codes that start with a 0, we can omit the 0, so this can also be written as M5 and the machine will read it just fine. M09 is our coolant off M code, so if the coolant is on, it will turn it off at this point. If it is not on, it will just skip this line and continue reading the rest of the program. Here we have our first tool call. Now a tool call tells the machine which tool to load into the spindle and which offsets that we're going to use. So T3 tells the machine we're using tool 3 that we designated with inside the controls, and M06 is our tool change M code. So if we have an automated tool changer, the machine will change tools when it reads the M6 and it will change it to tool 3, or it will allow us to do a manual tool change. With G-code, an S value normally refers to the spindle speed or the rotation of the spindle per minute. Now routers tend to run quite fast spindle speeds since we're cutting wood. So I've selected a spindle speed of 12,000 RPM, and the M code MO3 tells the machine to turn the spindle on in a clockwise direction. If we were to go anti-clockwise, we would use MO4. G54 sets our working datum. This means within the machine controls we have already told the machine where our datum position will be, so G54 just tells the machine to read that information, so all our dimensions and measurements come from the datum position on the bottom left hand corner of the part. Now here we have G41. G41 adds cutter compensation, so the cutter goes to the left of the component, whereas G42 would be right cutter compensation, so it would go to the right of the component that we are cutting. The D3 is the section of code here where we call upon the tool table offset. So this tells the machine to call the tool information from table 3 on our tool table, which also gives the diameter or radius of our tool. G43 is similar. G43 tells the machine to call upon the tool length offset, so we can see how long the tool is, so the machine knows exactly the tool length that we are using. We can set this on this line as well by using a Z value, so we can tell it that the tool is 15 millimeters long, or we can call that information from the tool table using an H value. So H3 would call that information from the tool table. So H calls for the tool length or the tool height from the machine controls, and D calls the tool diameter. M08, or simply M8, turns on our coolant. Now we get to our first line where we start moving the cutter around, the G00 command. Now G00 is the rapid travel command, so this moves the machine at its fastest permissible feed rate. So we don't need to issue a feed rate with G00 commands. The machine assumes that we're not cutting and the cutter is above the component. So it moves it as fast as it possibly can without damaging the machine. So G00 moves the cutter to its fastest possible way to our position of X 0.0 and Y minus 20 mil. Now why am I going to a minus number in Y axis? This is because I wish to start away from the component as I bring the cutter in. So rather than coming down right on X0, Y0, I've come off the Y axis by 20 millimeters so we can ramp into the job. This will give us a greater dimensional accuracy and surface finish as we start machining the part. Now as we move the cut around under our rapid travel command G00, it's still at its tool change height, its highest maximum Z height permissible. So we're going to rapid this down to 5 millimeters above the job. Now G00 is still active, so we'll do this at the fastest feed rate possible. Now I'm rapiding down to this point and not into the material because we can't remove material when we're using G00. It would move too quickly and possibly break the tool. So I'm rapiding down to 5 millimeters above the part so we can feed the tool down as we start cutting into the material. So now most of the distance of the cutter movement towards the material has been done by rapid travel. We can do the rest in a more controlled manner by using G01, our feed rate command. So G01 with a Z depth of minus 5 millimeters will take the cutter 5 millimeters deep into the material. Now I'm assuming we're using 5 millimeter thick material, so this will take us right the way through the material. We also need to issue a feed rate to tell the machine how fast we're going to come into the material. So a feed rate of 250 millimeters per minute would be suitable for softwood. So with our cutter to depth, we can speed up the feed rate a little bit as we feed in X or Y axes. So I'm going to add a feed rate of 300 millimeters per minute from now on while we're cutting this profile. Now G01 is still active from the line above, so we don't need to state that again. The machine already knows we're moving at a feed rate. We just need to declare a different feed rate. Now the first move I'm doing is I'm taking our cutter up the Y axis by 160 millimeters up from the datum. And because it's up from the datum, it's a plus figure. Now why 160 and not 180? Well, this takes us to the beginning of the radius. We have a 20 millimeter radius and I wish the cutter to be at the beginning point of that radius. So we're moving the tool 160 millimeters from the datum position. So we're now ready to cut our first radius. For that, we use GO2. This is our clockwise radial move. So it knows which way the radius is going. We simply have to state a center point of the radius and an end point to be able to cut this. So where our tool was at the start of the radius, we take the center point of the radius as an incremental move. Now we discussed this slightly at the beginning of this lesson. So the incremental move along the x-axis would be in I, because I, J and K represent X, Y and Z. So this would be a plus direction because it is to the right of the cutter and the dimension is taken from the cutter and not the datum position. This is going back to the G91.1 we had in the safety line where we told the machine any radial moves, the center point of the radius will be an incremental and not absolute. Now remember, absolute is the positions from the datum, where incremental is a position from the tool. So the X and Y positions here is the end point of the radius from the datum, because we're working in absolute through our usual control methods of this machine. But when it comes to defining the center point of the radius, that's an incremental. So I would be 20 millimeters, as that's 20 millimeters away from the start point of the tool along the x-axis, and Y would be in line with the tool, so this would be 0. So J would be 0 as that represents Y. So this line of code would move our cutter around a 20 millimeter radius with a center point 20 millimeters away from the x-axis and 0 along the y-axis, and we define our finishing point by using the x and y coordinates. So our next movement command is a simple straight line move. So for that we're going to use GO1. We need to declare GO1 again as the previous line had GO2. So we told the machine we were cutting radial, now we need to tell the machine we're cutting linear again. So we just need to give it an endpoint in the x-axis. We don't need to tell it the y position because it assumes it's not moving in y if we don't give it a dimension. And that takes us up to the beginning of the next radius. So like before, this is the same size radius as before, by the way. We're still using a 20 millimeter radius even though it's not marked on the drawing. I omitted this dimension so it didn't get too confusing and too cluttered. I like to keep these drawings very simple when explaining G-code. So as we move along to this next radius, we have to declare the endpoint using x and y coordinates and the center point of the radius using I and j. Now remember, I is x movement and j is y. So this time, where we're already in line with the x-axis with the center point of the radius, we would give it a command of I0 because the center point is in line with the center line of the cutter. But in y, we're 20 millimeters away because we need to move down towards the y-axis in 20 millimeters and it's in a minus direction. So we would put j minus 20 millimeters. Now as before, we are using a GO2 command for a clockwise radial movement. Following that is another straight line move, so for that we switch over to GO1 again. Now as we're switching between GO1 and GO2, we don't need to issue a new feed rate all the time. The original feed rate of 300 millimeters will stay active until we issue a new feed rate. Now sometimes we might want to slow the cutter down when machining radiuses. It totally depends on the way the machine handles the cut. So you might find it's cutting a little bit too fast on a radius and we can give it a slower feed rate as it approaches the GO2 line. So for this straight line move, we're coming down to a position that's 40 millimeters above the datum. We know this position because the radius is 40 millimeters. So GO1 Y40 will bring the cutter down to 40 millimeters above the datum position in the y-axis. Now our final radius here is a 40 millimeter radius. So for that we're going to use GO2 because it's still a clockwise radius and we're going to give it its endpoint. So the endpoint in x would be the distance from the datum to the start of the radius. Now the overall length is 180 millimeters, so 180 minus the 40 millimeters of the radius would give us 140 millimeters. So our x position is x140. Now because we're on the datum position on the bottom edge here, this is our datum edge, the y would be 0 because there is no movement in y and the cutter compensation already works out how much to offset the cutter by, so the edge of the cutter is touching this and not the center point of the cutter. So for our I and J values this time, where the cutter starts at the beginning of the radius, the I would be -40 in the x-axis, and we define that by using the letter I. So I -40 tells the machine the center point of the radius is 40 millimeters to the left of the cutter. And there is no position change in Y. So J, our Y axis, is 0, 0. This is because our cutter is already in line with the center point of the radius. Now all it's left to do now is to move the cutter back to its start position and a safe place where we can lift it from the material. So G01 x -20 will bring the cutter 20 millimeters to the left of our datum position. And that brings the cutter over to where it's shown on this drawing. So now we can lift the cutter away from the component and it won't be touching an edge of the component that we wish to keep nice and clean. We can use a feed rate to lift the cutter out of the material, but we can also do it in rapid mode. Because we finished cutting, we can lift that cutter right out of the material as fast as we like. So for that, I'm using G00, our rapid command. So bring that up to 15 millimeters. That's 15 millimeters above the surface of the material. Because remember, we set our datum position on the surface of the material, so any minus number would be cutting and any plus number would be above the material. So this is 15 millimeters above the material that the cutter lifts up to. With G00 still being active, we can now move our cutter back to its home position. Now this is the machine's home position we're talking about here. So I've declared that as X240, Y240. We can also add M09 to turn off the coolant at this stage. Now we can only add one M code per line. So normally if we have multiple M codes we wish to turn on or off, we would have them on their own separate line, but it's totally acceptable to have one M code on any other line of code. Now that the cutter is back in its home position, we need to turn it off. So to turn off the cutter, we use the M code M05, or we can shorten that to simply M5. So M05 turns off the cutter. Because we used cutter compensation on this component, where we defined G41 earlier on before we started moving, we now turn that off with G40. So G40 turns off cutter compensation. Finally, we have the M code M30. Now M30 tells the machine we've finished the program and to rewind back to the start and stop and wait for our next instruction. An alternative to this would be M99. Now M99 would rewind the program back to the start and then continue running. This is not normally used on CNC routers, this is more of a CNC lathe thing. So M30 tells the program it's finished and rewinds back to the beginning of the program and stops. So that was a rundown of a very basic program cutting a simple shape on a CNC router. Now for more complex shapes, everything would be the same. The layout would be the same, the M codes, the G codes, and the safety line at the beginning, and the way we end it using G40, M30, etc. The only thing that would make it more complex is there'd be more lines of positional code, the G01s, the G02s, and the G00s. So that is how we write a program using G code for our CNC routers.